Welcome to your personal deep dive, and today we're going deep into the world of zero-point energy. You sent us some fascinating notes and excerpts from lectures by Dan Winter and Elizabeth Donovan, and they're doing some really interesting work in this field.
It's a fascinating area for sure. Zero-point energy is this theoretical energy field that's it's thought to exist everywhere, even in a vacuum.
Okay, so before we go any further, can we break down what zero-point energy actually is? I mean, I know it's been touted as this potential source of limitless clean energy, but
Right.
I'll admit I'm a little fuzzy on the details.
It's definitely complex. Basically, imagine the universe at its smallest level, even in a vacuum, which we think of as empty space. There's this constant fluctuation of energy particles were popping in and out of existence, creating a sort of background hum of energy that never goes quiet.
Okay.
And that's what we call zero-point energy.
So even seemingly empty space is buzzing with potential energy. That's pretty wild. But if it's everywhere, why aren't we using it to power our homes and cars already?
That's the million-dollar question. Both Winter and Donovan believe that the key to this lies in this concept called implosive charge collapse.
Okay.
It's all about understanding how to make that energy accessible and usable.
Implosive charge collapse. It sounds intense. Can you unpack that a little more for us? What exactly does it mean?
Think of it this way. You have all this energy fluctuating randomly in a vacuum. To harness it, you need to create a specific set of conditions that cause the charge or energy to implode inwards.
Okay.
In a controlled way, releasing a burst of usable energy.
So it's not just about capturing the energy, it's about directing it, kind of like harnessing lightning instead of just letting it strike randomly?
That's a great analogy, and both Winter and Donovan suggest that a surprising element is key to achieving the golden ratio.
Wait, the golden ratio, like the mathematical concept used in art and architecture, what does that have to do with zero-point energy?
It's a fascinating connection. Winter, in particular, believes that the golden ratio is a fundamental principle of nature that governs the flow of energy. He suggests that incorporating this ratio into the design of devices can create the perfect conditions for this implosive charge collapse to occur.
So we're talking about building devices that mimic nature's energy flow patterns. That's a very different approach than what I imagine.
Absolutely. It highlights a key principle in Winter's work, that nature already utilizes zero-point energy in incredibly efficient ways.
That makes sense. So are there any real-world examples of how nature does this? I mean, besides the obvious things like the sun, which we haven't quite figured out how to replicate.
There are actually examples all around us. Winter often uses the pine cone as an illustration.
A pine cone? What does that have to do with zero-point energy?
The pine cone structure, with its spiraling scales arranged in a specific pattern, actually acts as a capacitor. A capacitor is like a container that can store electrical energy. Winter's research suggests that the pine cone's unique shape allows it to draw in and store energy from its surroundings, potentially zero-point energy.
So even something as seemingly simple as a pine cone can hold clues to unlocking this massive energy source that's pretty mind-blowing.
Exactly. And it makes you think about what other secrets nature might be holding. In fact, Winter also points to another much larger example, the pyramids.
Okay, now we're getting into the really intriguing stuff. You're not saying that the pyramids were powered by zero-point energy, are you?
Well, there's definitely a lot of speculation around that, but Winter proposes that the pyramids, with their precise geometry and placement, might have been designed to resonate with the Earth's natural frequencies.
Okay.
It's possible that they acted like giant antennas pulling in energy from the environment.
So not necessarily harnessing zero-point energy directly, but maybe tapping into some other forms of natural energy.
Precisely. And that idea ties back to the concept of conditioning the space, which is something that both Winter and Donovan emphasize.
Right.
It suggests that the environment you're in can significantly influence the flow of energy, including zero-point energy.
Okay, that's a really interesting idea. So it's not just about building the right device, but about placing it in the right location, almost like finding a good Wi-Fi signal.
Exactly. It's a fascinating aspect of their research, and one that many inventors trying to build zero-point energy devices might be overlooking.
Speaking of those inventors you mentioned, there are people actually trying to build devices that utilize zero-point energy. Can you tell us about some of the real-world examples they're working on?
One invention that comes up a lot in the materials you sent is the Joe cell.
Okay.
It's a device that supposedly uses concentric metal tubes to split water molecules and create hydrogen gas powered by zero-point energy.
Wait, so we're talking about a car that runs on water. That's pretty incredible if it's true, but you said supposedly is there evidence that it actually works?
That's where things get a bit murky. There are a lot of anecdotal accounts of the Joe cell working, but it seems to be very sensitive to the environment it's in. There are reports of it working perfectly in one location and then failing to function just a few miles away.
Ah, so this is where that conditioning the space idea comes back into play. Is it possible that these inventors are focusing so much on the device itself that they're neglecting the importance of the surrounding energy field?
That's a very astute observation, and it's a criticism that Donovan in particular levels at many in the field. She stresses that a deeper understanding of the underlying physics, including this concept of implosive charge collapse, is essential for creating devices that are truly reliable and effective.
So it's not enough to just build something that looks like it should work. You have to understand the principles behind it, especially when dealing with something as complex as zero-point energy.
Exactly, and that's one of the challenges facing this field. There's a lot of enthusiasm and experimentation, but also a need for more rigorous scientific research to really unlock the potential of zero-point energy.
It's a delicate balance, isn't it? Encouraging innovation while also ensuring that claims are backed up by solid evidence.
Absolutely, and that's what makes this field so fascinating, is pushing the boundaries of science and challenging our understanding of the universe.
Well, I'm already hooked. We've covered a lot of ground, but it feels like we've just scratched the surface of this whole zero-point energy thing.
We definitely have, and there's a lot more to unpack, including some mind-boggling possibilities like transmutation of elements, basically turning one element into another.
Hold on, are we talking about real-life alchemy here? That's straight out of a fantasy novel?
It might sound like magic, but it's a real area of research that Donovan is exploring. It's all about understanding the specific frequencies and temperatures required to rearrange the building blocks of matter itself.
This is incredible, but I think my brain needs a moment to process all of this. Let's take a quick break, and when we come back, we can delve deeper into the work of Winter and Donovan and the potential implications of their research.
Okay, I think I've caught my breath. We were just talking about this mind-blowing concept of transmutation, basically transforming one element into another.
Right.
It sounds like something out of science fiction,
Yeah.
but you're saying Elizabeth Donovan is actually researching this. It's based on the idea that everything in the universe is ultimately made up of energy vibrating at different frequencies, and Donovan's research explores whether we can manipulate those frequencies to actually change the structure of matter itself.
So we're not just talking about harnessing energy anymore. We're talking about manipulating the fundamental building blocks of the universe.
Yeah.
That's a whole other level.
It really is, and it gets to the heart of what makes zero-point energy so fascinating. It's not just a potential source of power, but it's a doorway to understanding the very fabric of reality.
I'm starting to see why this field is so captivating. It's not just about solving practical problems. It's about expanding our understanding of what's even possible. But let's bring it back to Donovan's research for a moment. How exactly does she go about trying to transmute elements?
Her work involves calculating the precise frequencies and temperatures needed to induce these transformations. It requires a deep understanding of both physics and chemistry, and a lot of experimentation.
It sounds incredibly complex. Are there any real-world examples of this kind of transmutation actually happening?
There are some anecdotal accounts and historical examples that suggest it's possible, but it's still a very controversial topic within the scientific community. Donovan's research is really pushing the boundaries of what we currently understand about matter.
So it's still very much in the experimental phase, but the potential implications are huge. I mean, imagine if we could create valuable elements on demand or even transform waste products into something useful.
Exactly. It could revolutionize industries from medicine to manufacturing and have a major impact on sustainability.
But before we get carried away dreaming about the future, let's talk about the challenges. What are some of the obstacles facing researchers like Donovan who are trying to unlock the potential of zero-point energy?
One of the biggest challenges is the lack of funding and support from mainstream scientific institutions. There's still a lot of skepticism around zero-point energy, and it can be difficult for researchers to get their work taken seriously.
That makes sense. It is a pretty radical concept, and I can imagine a lot of scientists are hesitant to embrace something that challenges the established paradigms.
Absolutely. It takes courage to go against the grain and explore uncharted territory, and then there's the issue of replicating results. A lot of the early work on zero-point energy was done by individual inventors working in isolation, and it can be hard to verify their claims or build upon their findings.
So we need more collaboration, more rigorous scientific testing, and more open-mindedness from the scientific community as a whole.
Exactly. It's a field that demands collaboration across different disciplines, physics, engineering, chemistry, even biology. And it requires a willingness to question assumptions and explore new ways of thinking.
It sounds like a very exciting time to be involved in this research, even with all the challenges. But let's not forget the work of Dan Winter. We talked about his focus on the golden ratio and how it relates to zero-point energy. Can you elaborate on that a bit more?
Winter's work delves into the geometry of energy flow. He believes that the golden ratio, which is found throughout nature, from the spiral of a seashell to the arrangement of seeds in a sunflower, is key to understanding how energy moves and interacts.
So it's not just a random mathematical concept, it's a fundamental principle of nature.
That's what Winter argues. He suggests that systems that incorporate the golden ratio are inherently more efficient at harnessing and transmitting energy, including zero-point energy.
Okay. I'm starting to see the connection. So if we want to build devices that effectively tap into zero-point energy, we should be looking to nature for inspiration, specifically at how the golden ratio is expressed in natural forms.
Precisely. It's a different way of approaching technology, one that emphasizes harmony with nature rather than trying to dominate or control it.
That's a really compelling idea, but how does this golden ratio principle actually work in practice? Can you give us a specific example of how it might be applied in a zero-point energy device?
Winter often points to the concept of a fractal antenna. A fractal is a geometric shape that repeats itself at different scales, like a tree branching out or a coastline with inlets and bays.
Okay.
Fractal antennas, because of their unique geometry, are able to pick up a wider range of frequencies compared to traditional antennas.
So by incorporating a fractal design based on the golden ratio into an antenna, you could potentially increase its sensitivity to subtle energy fluctuations like those associated with zero-point energy.
That's the idea. It's about creating a resonance, a harmony between the device and the energy field it's trying to tap into.
This is fascinating stuff. It's making me think about all the different ways nature uses energy and how we might be able to learn from those examples to develop new technologies.
That's exactly the kind of thinking that Winter and Donovan are trying to encourage. It's about recognizing the interconnectedness of everything and seeing energy not just as a resource to exploit, but as a fundamental force that shapes and sustains the universe.
Well, they've certainly given us a lot to ponder. I have a feeling we could talk about this for hours, but unfortunately we're running out of time. Before we wrap up, is there anything else you'd like to share about the work of Winter and Donovan or about the field of zero-point energy research in general?
I think the most important takeaway is that this is a field full of potential and possibilities. It's a reminder that there's still so much we don't know about the universe and how it works, and that there are people out there pushing the boundaries of knowledge and challenging us to rethink our assumptions.
I couldn't agree more. It's inspiring to see scientists and inventors like Winter and Donovan who are willing to think outside the box and explore ideas that might seem radical or even impossible.
And who knows, maybe one day we'll be looking back at these early pioneers of zero-point energy research as the visionaries who helped usher in a new era of clean and abundant energy for humanity.
That's a hopeful thought, but even if that future doesn't come to pass, the journey of exploring these ideas is valuable in itself. It expands our understanding of the universe and reminds us of the incredible potential that lies within nature.
Absolutely, it's a journey of discovery and one that I encourage everyone listening to join.
Well said. And on that note, we'd love to hear from you. What surprised you most about this deep dive into zero-point energy? What questions do you have? Share your thoughts on our website, and let's continue the conversation.
I'm looking forward to hearing what our listeners have to say.
It feels like we've taken a crash course in quantum physics and ancient mysteries all rolled into one, but I have to say I'm really intrigued by this idea that the golden ratio is not just some abstract mathematical concept, but a key to understanding energy flow in the universe.
It is a fascinating concept, isn't it? And it challenges us to think about technology in a different way, one that's more in tune with nature's principles.
I remember learning about the golden ratio in art class, but I never imagined it would have applications in energy research. Do you think this is something that mainstream science is starting to take seriously?
It's definitely still on the fringes, but there's a growing body of research that suggests there's something to it. For example, some studies have shown that fractal antennas, which are based on the golden ratio, can be more efficient at transmitting and receiving signals.
So there's real-world evidence to support these ideas, at least in some areas. That's encouraging, but I'm curious, if the golden ratio is so fundamental to energy flow, why haven't we been incorporating it into our technology all along?
It's a good question.
Mm-hmm.
I think part of it is that our current technological paradigm is very linear and reductionist. We tend to break things down into their smallest parts and try to understand them in isolation. But the golden ratio is all about interconnectedness and wholeness.
So we've been looking at things too narrowly. Maybe we need to shift our perspective to see the bigger picture, the patterns and relationships that connect everything.
Exactly, and that's what Winter and Donovan are advocating for. They're encouraging us to move beyond a mechanistic view of the universe to one that recognizes the inherent intelligence and creativity within nature.
It's a pretty radical shift in thinking, but it's also very exciting. It opens up so many possibilities for innovation if we're willing to look at things in a new way.
Absolutely, it could lead to breakthroughs in everything from energy production to communication to healing. It's about tapping into the inherent potential that's all around us if we know how to see it.
Well, they've certainly opened my eyes to a whole new world of possibilities. But before we wrap up, I have one more question. We've talked a lot about the science of zero-point energy, but what about the philosophical or even spiritual implications? Does this research challenge any of our fundamental beliefs about the nature of reality?
I think it definitely does. For centuries, we've been taught that matter is the fundamental building block of the universe. But zero-point energy suggests that energy is actually the primary reality, and that matter is simply a manifestation of energy.
So instead of seeing the universe as a collection of separate objects, we should be seeing it as a web of interconnected energy fields.
Exactly, and that has profound implications for how we understand ourselves and our place in the cosmos. It suggests that we're not just isolated individuals, but part of a larger interconnected whole.
It's a very different worldview, and it's one that I'm finding very appealing. It feels more aligned with my own experiences of the world, where everything seems to be connected in some way.
I think a lot of people are resonating with that idea in a world that often feels fragmented and divided. The concept of interconnectedness through energy offers a sense of hope and unity.
It's a reminder that we're all part of something bigger than ourselves, and that we have the potential to tap into that energy to create a more harmonious and sustainable world.
Beautifully said. I think that's a perfect note to end on.
I agree. This has been an incredible deep dive, and I want to thank you for guiding us through this fascinating and complex topic.
It's been my pleasure. I always enjoy exploring these cutting-edge ideas, and it's been wonderful to share them with our listeners.
And to our listeners, we hope this deep dive has sparked your own curiosity about zero-point energy and the incredible potential it holds. If you'd like to learn more, be sure to check out our website for links to the research of Dan Winter and Elizabeth Donovan, as well as other resources on this fascinating topic.
And as always, we encourage you to keep exploring, keep questioning, and keep an open mind to the mysteries of the universe.
Until next time, stay curious.